Hello guys, welcome to this another video, and today we will going to discuss what is FIFO, LRU and optimal page replacement algorithm and how they works. Okay, so let's start with FIFO page replacement algorithm. So FIFO means first in first out, and we know that it is the property of a queue. And what do you mean by page replacement? I already discussed it in my previous video, so if you did not see it, just go and check it out. So actually what happens in FIFO page replacement algorithm, so suppose all the page frames are filled with different pages. That means the RAM is already full with different pages. Every frames of RAM contains different pages. And now a new page request occurs. And the fact is this required page is not present in any frame of the RAM. So then what happens? Operating system starts to find that page inside the secondary memory, and when finally operating system will find out that page inside the secondary memory, then that required page will transfer into the frame inside the RAM. But now here the question is, already all the frames contained different types of pages, so where that new page will come? Okay, so what happens actually, operating system will swap out a page from the frame, but which page OS has to swap out from the frame? So here the different types of page replacement algorithm comes, and what FIFO says that the page which came first inside the RAM, that will swap out from the frame, and the new page, that means our required page, will swap into that empty frame. That means FIFO says that the page which came first inside the RAM, that will be replaced by the new page. Okay, so this is actually FIFO page replacement algorithm. Let's take an example. I think it will clear the conception that how FIFO page replacement algorithm works. This type of numericals also come in your exams. So suppose there are page requests 5232713451. Assume there are 3 frames in RAM. Show the page replacement by FIFO algorithm and calculate number of page hits, number of page faults, hit ratio and miss ratio. Now what is page hit and page fault? Page hit means when a page is requested, and if that page is found inside the RAM, then that is known as page hit. And if the requested page is not found inside the RAM, then that is known as page fault. So these are our page requests, and here RAM contains 3 frames. So now what happens? Our first requested page is 5, and 5 is not present inside the RAM, so it is obviously a page fault. Then 2 is requested, and 2 is also does not present inside the RAM, so it is also a page fault. Then 3 is requested, 3 is also not present, it is also a page fault. Then 2, it is present inside the RAM, so it is a page hit. Now here the fact comes that now all the frames contains different pages, and now our requested page is 7, and 7 is not present inside the RAM, so it is obviously a page fault. And now according to FIFO algorithm, which page came first inside the RAM? That is page 5. So we have to replace page 5 by page 7. So what happens? Page 5 is swapped out from the RAM, that is page 5 is replaced by page 7, so it is also a page fault. Now what happens? 1 is requested, and between 7, 2 and 3, which page came first? 2 came first, so 2 is replaced by 1, and that is also a page fault because 1 is not present inside the RAM. Now the requested page is 3 and it is present inside the RAM, so it's a page hit. Now the requested page is 4 and it is not present inside the RAM, so it is obviously a page fault. And between 7, 1 and 3, which page came first inside the RAM? That is 3. So 3 is replaced by page number 4. Now the requested page is 5 and it is also not present inside the RAM. So it is obviously a page fault. And between 7, 1 and 4, which page came first inside the RAM? That is page 7. So 7 is replaced by 5. Now the requested page is 1 and it is present inside the RAM. So it is obviously the page hit. So that is how FIFO page replacement algorithm works. So here the total number of page hit is 3 and total number of page fault is 7. Here red denotes page faults and green denotes page hits. Now what is hit ratio and miss ratio? How to calculate it? So hit ratio means number of page hit divided by total pages. So that is 3 by 10. And what is miss ratio? Miss ratio means number of page fault divided by total pages. That is also calculated by 1 minus hit ratio, and that is 7 by 10. So that's all about FIFO page replacement algorithm. Now proceed to our next page replacement algorithm, that is LRU page replacement algorithm. So what do we mean by LRU? Here LRU means least recently used. So actually what LRU tells that here the story is similar to the previous one, but the fact is in FIFO page replacement we have to swap out the page which came first inside the RAM. But here the story is something different. In LRU page replacement algorithm, the page which is least recently used, that will swap out from the RAM. Okay, so here in LRU page replacement algorithm, the new page is replaced with the least recently used page. Okay, so that is how new page will come inside the RAM. Now let's take an example like previous one. So suppose there are page requests 2, 3, 1, 2, 4, 1, 6, 2, 5, 4. Assume there are 3 frames in RAM. Show the page replacement by LRU algorithm and calculate number of page hits and page faults, hit ratio and miss ratio. So this is like previous one, but here we have to solve it by LRU page replacement algorithm. So let's see that how can we solve this. So these are our page requests. Here RAM contains 3 frames. So here 2 is requested and 2 is not present inside the RAM, so it is obviously a page fault. So then 3 and 3 is also not present inside the RAM, so that is also a page fault. Thereafter 1, that is also a page fault. Thereafter 2 and 2 is now present inside the RAM, so that is a page hit. Now 4. So between 2, 3 and 1, which page is least recently used? So we have to see in the backward direction. So 2 is most recently used, then 1 is used. So 3 is least recently used because it is used earlier. So between 2, 3 and 1, 3 is least recently used. So we have to replace 3 by the requested page 4. So 4 is not present inside the RAM, so that is obviously a page fault, and 3 is replaced by 4. Now 1 is present inside the RAM, so that is a page hit. Now 6 is not present inside the RAM, that is page fault. and between 2, 4 and 1, which is least recently used. 2 is least recently used, so 2 is replaced by 6. Now the page request is 2. 2 is not present inside the RAM, that is page fault. And between 6, 4 and 1, which is least recently used, that is 4. So we have to replace 4 by 2. Now the requested page is 5, and 5 is not present inside the RAM, so it is obviously a page fault. And between 6, 2 and 1, which is least recently used, that is 1. 1 is least recently used, so 1 is replaced by 5. Now the requested page is 4, so it is also not present inside the RAM. It is also a page fault. And between 6, 2 and 5, which is least recently used, that is 6. So 6 is replaced by 4. So now according to our problem, all the page requests are over. So that is how LRU page replacement algorithm works. So here the number of page hit is 2 and number of page fault is 8. So like previous one, here the hit ratio is 2 by 10, that is 1 by 5, and the miss ratio is 8 by 10, that is 4 by 5. So that is all about LRU page replacement algorithm. Last but not least, we move to the next page replacement algorithm, that is optimal page replacement algorithm. So in optimal page replacement algorithm, the story is similar to like previous two page replacement algorithms, but the fact is in FIFO page replacement algorithm, we have to swap out the page that came first inside the RAM. In LRU page replacement algorithm, we have to swap out the page that is least recently used. But here in optimal page replacement algorithm, the page which is used most later, that will swap out. So actually here we have to know that what are the pages that will use in future, and the page which is used most later, that page will swap out from the RAM. So here the new page will swap inside the frame, and the page which is used most later, that will swap out from the frame. So just take an example. So I think the example will clear your concept about optimal page replacement and how it works. So just move to the example. So suppose there are page requests 2153425125. Assume there are 3 frames in RAM. Show the page replacement by optimal page replacement algorithm and calculate number of page hits and page faults, hit ratio and miss ratio. So let's see that how this problem can be solved by optimal page replacement algorithm. So these are our page requests. Our RAM contains 3 frames. So the now first requested page is 2, and that is not present inside the RAM. So that is obviously page fault. Then 1, it is also not present inside the RAM. It is obviously page fault. Then 5, it is also not present inside the RAM. So that is also a page fault. Now 3. So we have to see in future that between 2, 1 and 5, which page will going to use in most later. So between 2, 1 and 5, page 1 is used most later. So we have to replace page 1 by page 3. So page 1 is replaced and page 3 comes inside RAM, and it is obviously a page fault because 3 is not present inside the RAM. Now 4 is not present inside the RAM, so it is obviously a page fault. And between 2, 3 and 5, which is used most later, so here 2 is present, 5 is present, but we can see that in future 3 is not present in our page requests. So we assume that 3 will use in far future. So here we have to replace 3 by 4. So 3 is replaced and 4 comes inside RAM. Now 2. So 2 is already present inside the RAM, so that is a page hit. Now 5. 5 is also present inside RAM, that is also a page hit. Now 1. So 1 is not present inside RAM, so that is a page fault. And between 2, 4 and 5, we can see that 2 and 5 page requests are available in future, but 4 is not present here. Page request 4 will not occur, so we can assume that it will use in further future. So 4 is replaced by 1, so 4 will swap out and 1 comes inside RAM. Next 2 is present inside RAM, so that is a page hit. Then 5 is also present inside RAM, so that's also a page hit. So now our all page requests are over. So that is how optimal page replacement algorithm works. So here number of page hit is 4, number of page fault is 6. And like previous two examples, here the hit ratio is 4 by 10, that is 2 by 5. And similarly miss ratio is 6 by 10 or 3 by 5. Finally, we're done with FIFO, LRU and optimal page replacement algorithm. So that's all for the day, and in the next video I will discuss another page replacement algorithms. So there is a set of problems from these algorithms are already given. You can download it from the link given below. Here is the link. This link is also available in the description box. So just click on the link and download the question set and then solve it. So you can also mail me the answer sheet on byte2bytelearn@gmail.com. So I hope this question set will help you, and I think you guys already understood these 3 page replacement algorithms. So hope you guys enjoy this slide. So please like the video, share the video with your friends, and please subscribe to our channel. So see you in the next video guys. Stay home, stay safe.